Intermediate Algebra Mid-Course Assessment, Questions 14, 15, and 16. We're going to continue with the same instructions that we had in the previous few questions, which was to factor completely. Here I see I have a 54k to the third m minus 250 m to the fourth power. First thing I'm going to do is look for the greatest common factor. The 54 and the 250 are both even. That means that a 2 will divide out. So I'll divide out a 2. With the 2, I'm also going to take an m because they both have at least one m in common. So 54 divided by 2 leaves me with 27. Then I come over and I divide the m into the m, and that cancels the m's down to a 1. So I'm left with 27k to the third minus. Now I'm going to come over and divide the 2m into the 250m to the fourth. A 2 into 250 creates 125. An m into the m to the fourth, I'm going to subtract the exponents, so 4 minus 1 to create a 3. So I end up with 125 m to the third power. Now when I look at this, I have k to the third and m to the third. And I have a minus sign. I want to see if this is a difference of cubes. So I come back and I look at the 27. I can cube that. I can take 3 times 3 times 3 to make 27. So 3 to the third power. The same with the 125. I can take 5 times 5 times 5. So I can cube this to make 5 to the third power. Now, in the difference of cubes, if I have a base a raised to the third power minus the base b raised to the third power, then I can rewrite it in a factored form of a minus b times a squared plus ab plus b squared. So let's go ahead and plug this information in. So I know that I have the 2m to the outside. Nothing's going to change on that. I divided the greatest common factor out. That 2m is going to stay outside in the front. For the base, in the a position, I have a 3 and a k. So I'm going to plug that 3k into the binomial according to my rule above, followed by subtracting what's in the b position on the bases, which is a 5 and an m, 5m. Then I'm going to move over and I'm going to take the a position and square it. So that's going to be the 3 and the k both squared, plus my a times my b to the center, so 3k times 5m, followed by summing whatever's in the b position squared, which is my 5m, both of them squared. Now I just need to come back up to the next row and just clean everything up. The 2m, 3k minus 5m, just copy as is. I'm going to take that 3 to the second power, 3 times 3 to make my 9, k to the second. Then to the center here, I'm going to multiply my 3 and my 5 to make a 15 and pull together the k and the m. So 15 times k times m, plus my 5 to the second power, which makes a 25, m squared. And so I factored it completely. Moving down to number 15, I have the same kind of problem here. This one, instead of being difference of squares, is now sum of squares. I can see that I can take 64 and cube it. 4 times 4 times 4 makes 64. S to the cube plus, now with the 1 I can also cube it because 1 times 1 times 1 still makes 1. So the only change when I go to factor here is that the binomial at the front, instead of being subtraction, is an addition, and the trinomial on the back side ends up with a minus in that second position. So I end up with my base 4s plus 1, and then my 4s both squared, minus my 4s times my 1, which is my a times my b, plus my b position, which is a 1, squared. Come down, finish it up, just clean it up. I have a 4s plus 1 times a 16s squared minus a 4s plus a 1. Now, for question number 16, I have an x to the second power minus a 3xy minus a 28y squared. I don't have any greatest common factors, so I'm going to go straight to working or factoring this out. I don't have anything in the a position, so I just need to deal with with what's in my C position and what's in my B position. Well, if I look at what's in my C position, it's a negative 28, but not just the negative 28 this time. It also has a variable attached. So I need to take that with it. So it's a negative 28y to the second. So when I go to pull what's in my B position, I'm going to pull out my negative 3, but I'm also going to pull out my y because I pulled a y out on the C position. So it's my negative 3y. So I'm going to look for factors that create a negative 28y to the second that sum together to create a negative 3y. Usually we would start right at the beginning. We would start with a 1 times the 28. And I'm going to start with this because I need a negative on that 28. One of my two factors needs a negative, but I need this kind of here so that I can see which one should get the negative. Right? So I'm going to come back here. I look at it. Right? If I were to put a negative on both, well, that would create a positive. That's not going to work. There's a slight error in here. This negative, extra negative right here shouldn't exist. Right? So that I have here a positive 1y times a negative 28y makes a negative 28. Then a positive 1y plus a negative 28 will make a negative 27. So there's a minor error. And if you see this back on your review pages, you might want to correct that. But now I can see that the negative, so that I get a negative on the 3, has to go on the larger of the two numbers. Now I could go down from there and do a 2 times, then see if there were 3 times, and so on. But if I kind of just know my multiplication, I know I need to go to a higher number. I could skip down here to 4 times 7. That makes a 28. And I know that the two numbers, once subtracted from one another, make a 3. So I put the negative on the 7 so that when I come over here to sum them, I get a 4y plus a negative 7y equals a negative 3y, which is what I want here. Okay, so coming back and looking at the problem, I'm going to take the x from the first position. I'm going to write this as a binomial so I can write my parentheses for both, put my x's in, and then take the factors that I found and plug them in, one into each position. So plug in the 4y, plug in the minus 7y. Now I factor completely.